Welcome to the next video for the LeetCode series that we have going on at DSC FIU. The problem that we have here is a beginner problem regarding linked lists. The problem that we have today is to reverse a linked list. This is a popular problem that is given across interviews, including different companies such as Adobe, Amazon, Apple, Facebook, Microsoft, all of these wonderful companies. So if you want to be ready for the interviews, you got to make sure you know this problem. So what is the problem? So given the head of a singly linked list, reverse the list, and return the reverse list. It's as simple as that. So we're given a sample here, 1, 2, 3, 4, 5. We want to return 5, 4, 3, 2, 1. And you'll see for the other examples, 1, 2 will return 2, 1. So we have a drawing here of the first problem here, 1, 2, 3, 4, 5. So what can we do? What is an approach that we can maybe take that will allow for us to reverse the numbers 1, 2, 3, 4, 5 into 5, 4, 3, 2, 1? Well, with the power of pointers, we can go ahead and try to reverse each linked list or each node in the linked list node by node so that we can get the entire linked list totally reversed. And we don't necessarily need a completely new list or anything like that. We can actually do this in place so that it's possible to just return the same linked list that we have, but just reversed. So let's go ahead and maybe let's start drawing out what we can do here, right? So what we can do essentially is that we can go by through each linked list, each node in the linked list, and more or less just flip the directions. And if we return this, we will get 5, 4, 3, 2, 1, which will be our answer. So that big overview, that's how we'll be able to do it. But that doesn't really tell us anything, right? How can we actually solve the problem? Well, let's analyze and see how we could actually change the order of the linked list from, for instance here, to make it go from 2 to 1 while still being able to iterate through the rest of the linked list. So what we want to do is to be able to return the 5 at the end. So what we should do is let's keep a track of a variable. Let's have a variable keep a track of what the past number is. So now when we're moving, when we're trying to link the last thing or try to reverse the order that we will end up getting the right order. So let's keep a node for previous. Let's start it off at null for now. Oh, let me actually do this in a different color. Previous equals null. We start with null because, well, think about it. When we go through a linked list, the element that happens after here will be null after 5. There's nothing else after that, so it will be null. So I will start off with null, and then we'll keep building from there. Then we'll have to keep a track of what the head, this is the head, the beginning of the linked list. We need to keep a track of the head, which will help us be able to iterate through the linked list. Current will equal the head. Okay. And as we go through the current, so current will allow for us to we'll be able to go through the list while building this list in essence. So while we're going through the list, So we need to go through the list until we reach the last value, which is null. So I'll head is not equal null, or it is, that's the same thing as this right here is not, same thing in pseudocode. Let's have a next. Which will be our current. Let's see why I'll do this in a second. And then we'll do current. Then we'll actually change the current dot next equal to the previous. Okay. So let's maybe take a bit of time out here. What are we doing? So we have next, which is being equal to current.next. So if we were to take the first example to an account, right? Let's think. Next, so we were trying to go through the whole list, which is why head is not equal to null, or is not null. While it's not that way, the next we'll go through. We'll keep the current.next so that we could change current.next. So current right now is the head, so we're actually gonna current, right? Current is pointing at 1, and what we need to do, so the current.next, so next will actually be, this will be next, and then we could change the current.next to the previous. So what's actually being built out here right now, so this is current is 1, but then current.next is the previous, so the previous is null. So you could see kind of how we're going to start building this backwards, and then we'll need to update our previous so that we can keep building, right, the beginning stuff. So let me I'll actually build this out, right? I'll build this out here so you could see from scratch, right? So right now we got null, and then 1, right? This is the current stuff. This is what we're building. Let's go ahead next, and we'll have the previous dot next, or what am I even saying? Not previous dot next. It's my apologies. It's just previous equal to current. So current, remember, current is equal to 1. So current is previously equal to null. So we want to now, so previous was here, now prev now will be updated to here. So you'll be able to get the next thing that'll have to be added to the list, and then you'll be able to we'll be able to keep building this list up in the opposite direction. And then current will be equal to next, and then we could return the previous. And okay, why are we setting the next to current? Well, the reason we're doing that is so essentially, so what is next, right? Next is current.next. So yeah, so we kept this as a variable so that we can keep moving forward with our linked list. So current equals current.next, or current, equals next. So now now that this is pointing this way, we'll actually now be able to get here and then work with this to here. So let's just let's do this again real quick, and so we can go through the whole actions. You can see it all completely in play. So next equals current dot next. So current, so this is now current. Okay, current equals next, so this is current. Current dot next, so this is what next is. Well, current dot next equals the previous, so we're going to change now whatever is a current dot next to previous. What previous is now is 1 from our last example. So current dot next, so the actual number that's pointing, it's actually this here. So now we'll actually be able to put 2. This current is actually now pointing to all of the stuff that we built before. Now the previous should now be 2 because we want to be able to set that number, that node next when we add it up, and then current that equals next, and next will allow for us to now move here, and this will keep iterating through, and eventually you'll get 4 and 5 by doing this whole thing, and this will be your answer. Okay, well, let's go ahead and code this up and see what we'll get as a result. So like I mentioned before, we need a previous variable. Also, I'm coding this in Java. You can code this up in any language that you like, and the algorithm overall should work the same way. So while current not equal to null, we're going through the whole original linked list. List node next equals current dot next. Current dot next equals the previous. Previous equals current, and current equals next, and we'll return the previous. Let's run the code. Let's submit. Perfect. It says that we have gone accepted faster than 100% of Java linked list solutions, and it takes up a little bit of memory. So what is the runtime for this? Well, the time complexity for this is O of n, because we'll be iterating through the whole linked list, and we will be we'll have to access every element in the linked list so that we can reverse it. And the space complexity is O of 1 because we do it in place. Thank you so much for listening to the video, and I hope you now understand the linked list, reversing the linked list problem better. If you like this video, please give us a thumbs up and comment in the section what you think about the video. And if you would like to join our Discord server to get more information about DSC and learn all about how to become a better competitive programmer, make sure to join in the link in the description. Thank you so much, and I hope you have a great day.